Now in the previous lecture we have learned how can we insert a node in a binary search tree, and hopefully everything is clear about insertion. Now in this lecture we will learn how can we traverse through a binary search tree. Basically it's the same as the way that we traverse through binary tree. So here I'll just quickly recap them. So let's say we have a binary search tree like this and we want to traverse all nodes of this binary search tree over here. So as I mentioned before, in this case we have 4 traversal. So the first 3 belongs to the depth first search, and the last one, which is level order traversal, belongs to the breadth first search. Now here the first one is pre-order traversal, then in-order traversal, then post-order traversal, then at the end we have to traverse through these nodes using level order traversal. So let's get started with the first one. So the first one is pre-order traversal. Now in case of pre-order traversal, as we said before, first we are looping root node, then left subtree, then right subtree. So in case of these 3 over here, it's going to be like this. First we are visiting this root node, then we are visiting left subtree, then we are visiting right subtree. So inside this left subtree we can see that we have another left subtree over here. So this means that when we are visiting this left subtree, we have to implement the same logic for this left subtree over here. So in case of pre-order traversal, the traversal of this binary search tree over here will be like this. So the order of the visit will be like this. We are starting from 70, then 50, then 30, then 20, then 40, 60, 90, 80, and at the end 100, which is the rightest node in this binary search tree over here. So as you can see from here that when we are starting pre-order traversal, we are starting from the root node, then we are continuing to the left subtree. So in the left subtree we are implementing same logic, which is starting from the root node, then left subtree, and here also we are implementing the same logic, starting from root node, then left subtree, then right subtree, and it continues like this. So this is how pre-order traversal works in case of binary search tree. Now based on this logic, we are going to create our pre-order traversal in practice. So let's head over to Java. Now here inside this binary search tree class that we created before, I'm just going to quickly create our pre-order traversal. So as I said before, this is going to be the same as in case of binary tree. That's why just I'm going to quickly create it over here because I have explained this one in detail. So the name of method will be pre-order traversal, and it will take as a parameter binary node. Then we are going to check that if the node is equal to null, in this case we are going to return, because in this case we have reached the end of the binary search tree. So I'm just going to return. Then we are going to continue visit first root node, then left subtree, then right subtree. So this means that we are going to call this method for left subtree and for right subtree. So before calling it for left subtree, we have to visit the root node. So that's why I'm putting the value of root node to the console by printing out it. So it's going to be like this, node.value. So for making our output more readable, I'm just adding space after this node over here. Now then we are going to call this method for left subtree, then right subtree. Node.left, then it's going to be node.right. So with this we have completed our pre-order traversal. Now let's see how this is working in practice. So here inside main class we have created our binary search tree like this. Then we have inserted these elements to this binary search tree over here. Now for simplicity, I'm just going to comment out this message inside the insertion method because I don't want to see it in the console for now. So then inside main class, I'm going to call our pre-order traversal. Now here in this picture, you can see the order of the elements in case of pre-order traversal. So this is the tree that we created over here. So the order over here has to be same as the output that we are going to get from this method over here. So I'm just going to call pre-order traversal. So here we need to put root node, new binary search tree dot root. Now if I call our method, so here I have an error. I have forgot to put the void over here. Now after running, you will see that our output looks like this. So it is same as the order that we have shown in this picture over here. So this means that our pre-order traversal works the way that it should be. Now let's see what's the time and space complexity for this method over here. So it's obvious that the time complexity for this method will be O(n) because in this case we are visiting all elements of the binary search tree. So this means that if the number of elements is n, so the time complexity will be O(n). Now the space complexity is also O(n) because in this case we are calling pre-order traversal recursively for left and right child. So this means that it's going to insert all elements to the stack memory for the next runs. So that's why it will take O(n) space complexity. Now with this we have come to the end of this lecture. So hopefully everything is clear about pre-order traversal. Now in the next lecture, let's look at in-order traversal in case of binary search tree. So see you in the next lecture.